All right, dude, we are live. What's up, guys? This is Dem Keys, and today we are going to continue working on the content pipeline. Um, Unfortunately, I started the stream a little later than I would like to, and so maybe we're only going to be able to stream for like an hour. I'm not sure. I'll try an hour and 15 minutes if possible, but yeah, it is what it is. I'll try again tomorrow. Hopefully tomorrow I'm able to start earlier, depending on whether I have to cook or not. Uh, okay, give me a second. Okay, all right. So I have been busy with what have I been doing? I've been busy working on steps for the content pipeline. I was trying to figure out what is a good approach here, and I believe um, I've got the entire thing down at this point. Like the entire content pipeline is ready. The generation of the segment data or the segment manifest, and then the eventual extraction of the segments. That was like that was in fact that was the main goal of this entire pipeline. All of the other stuff was just pre-processing that needed to be done in order to eventually, be able to extract these segments and uploading the YouTube video. It's just an extra feature that I wanted to add in because that's that's something that I do anyways. So I was like, okay, why not make that part of the pipeline as well? Um, and this is, to be honest, this is only gonna work if I don't have like a backlog of VODs. Or what I could do is, let's say if I'm starting with a backlog of like 1 month ago, like so far, um, up until now, I've only managed to upload up to as in January 20th of this year. I still have everything after Jan 20th to upload. Give me a second. I need to open up my chat on my phone. I also just remembered that I forgot to look into that the chat source issue. Why the chat source is not working. Um, Either way, it's a small thing. It's a small like on-screen thing which I bet I barely even use it. Um, what was I saying? I forgot where I was exactly. I was saying that damn, I I completely lost what I was talking about. Uh, right, I was talking about I guess I was somewhere in uh what just happened, dude? I just blanked. Holy shit. Give me a second here. Okay. Yeah, okay. Uh, Whatever. I can't remember exactly what I was talking about. I was saying something about like I've only managed to upload up to January 20th of this year, as in only um the VODs up to Jan 20th have been uploaded, and in fact, um the I think 17th, 18th, 19th, and 20th. I uploaded it just yesterday. And today I'm going to be uploading hopefully 21st to the 25th, and then hopefully tomorrow the remaining, and then I'll start with Feb. So what I could do is, let's say by chance, if within the next 10 days, actually not the next 10 days, let's say within the next couple of days, if I manage to set up this entire, because like dude, the segment manifest, that is quite literally the meat of this entire operation. um well, segment manifest and the metadata. So the metadata is also partially important because actually, okay, the metadata is more important for the YouTube upload because it's literally only going to be used for the YouTube upload. Though this just occurred to me, I could use some of the data that's being generated during the metadata generation. I could use some of that same data in the segment manifest generation. Um, but I mean, they're both operating on the same transcript file or on the same transcript. They're both going to be, you know, analyzing the same transcript. If there is a situation where I need to generate like a short summary, then yeah, sure, I could use the already generated summary, and that'll be one less extra bit of work that I have to do. But I mean, other than that, for the most part, it's all going to need to be generated from scratch. So now I guess two things that I need to work on. Now that we have this conceptual workflow set up, I guess two things that we have to work on, um, at least for the time being, because there's a bunch of stuff to work on. We have to work on generating the metadata. We have to work on generating the segment manifest. We have to then work on the YouTube upload script, and finally we have to work on the segment extraction script as well. There's a bunch of work to be done here. There's a bunch of logic that I have to come up with. Fortunately for FFmpeg related stuff, I mean, okay, extracting VOD segments, it's mainly gonna be an FFmpeg operation, or well, a bunch of FFmpeg operations. It'll take however long it takes, because the script is going to be calling out to FFmpeg. It's going to be using, I guess, subprocess.run to call out to FFmpeg and run whatever operation it needs to run. And FFmpeg is going to handle everything else. And this is going to be done like once per segment. So if one VOD bundle or one segment manifest happens to have like, I don't know, 10 to 15 segments, then this operation is going to be running 10 to 15 times. And this is not going to be a simple slice. We're not just going to be specifying, a start and end timestamp and just slicing out the video from there. We're going to specify the start and end timestamps, and then slice it out and re-encode the video. Because due to how these MP4 containers work, if we don't re-encode it, then certain information within the container itself is going to cause weird glitches, and there's a chance that there might be desync. There's a chance that at the beginning we might see either a black frame or a frozen frame for a couple of seconds, or there's going to be weird glitches. If I want like a proper quality slice, then I'll have to do the additional re-encoding step. The good news is that it's not a bunch of work that I have to do. It's just an extra flag or an extra bit of information I'll have to pass on to FFmpeg, and then FFmpeg is gonna do the re-encoding each time it slices out a segment. The only, I guess you can call it, downside is that this is going to be CPU intensive because, re-encoding. But I don't think that's that big of a deal, because it's kind of like, imagine you open up your video editing application, which these video editing applications have to do this exact same thing, by the way. They would also be re-encoding. There's a bunch of, dude, working with video containers, I've learned that there's a bunch of work that these video editing applications do that we quite often don't really learn about it unless we are working with the technology on a lower level, which is kind of what I'm doing here, or unless we are implementing the technology ourselves. We don't really learn about a bunch of these extra operations that the video editing applications have to do. There's a ton of work that these applications do in the background, which is why the application itself tends to, be a little on the heavier side. And also, this is also why exporting your video takes some time, because there's definitely 100% there's re-encoding going on there, because if they don't do that and they just let you slice out segments from the video, there's going to be information that hasn't been synced up properly. There's going to be information that's either missing, or whatever other kind of um, errors could occur from not re-encoding the video. It's actually really interesting when you look into this technology and how the technology works. It's pretty interesting, because like, when you look into why you would have these problems. For example, when you look into why you would have these problems if you didn't re-encode, just have a conversation with Gemini about this. Gemini does a great job of explaining this, and I'm guessing each of these different file formats would also have their own little quirks here and there that need to be handled by the video editing application. But yeah, okay, going back to what I was talking about. Even if you tried to, like, if you opened up a video editing application and set marks in certain locations, and then told the application to export all of those start and end marks at once, it would have to do what I'm planning on doing manually through FFmpeg. Your video editing application would have to do the same thing. And so even there, there would be a certain amount of CPU time being used up. So I mean, I'm not complaining that, I'm gonna have to do this, because in the end, this is gonna produce clips that I'm gonna be able to upload. And the idea is, I want to, at the very least, be able to upload videos daily. But if I end up with enough clips, hopefully this could turn into multiple uploads a day. I'll have to see how to go about doing that, because, I mean, I have daily streams at this point, which I'm glad about. That this year so far, I've only taken a few days off, and honestly, all of those days, it's not like I wanted to take a day off. There were certain reasons why I wasn't able to stream. Um, but fortunately, and we are currently in the middle of March, so we are in like the third month of this year, and so far, the the objective of doing daily streams is going pretty well, even though, there have been days when I didn't stream. Um, Fortunately, most of the days I have streamed out of the, what, 2.5 months that have passed in this year. Holy shit, dude. We are already like 2.5 months into this year. That's crazy. Okay. Anyways, so at the end of this extract VOD segments thing, we're gonna end up with a bunch of clips, and I'm wondering if I should maybe offload even this to the cloud. I don't think that would be necessary though, because like while yeah, sure, it would take a bunch of CPU resources. I don't think that's that much of a problem, because like if I just give it some time, I'm not in a rush to get the data. I'm not in a rush to get the clips. So even if the clip or the entire script, like the entire like VOD extraction process or segment extraction process, even if that entire process takes, I don't know, even if that entire process takes, let's say, I don't know, half an hour, I'm okay with that, because at the end of that, I'm going to have a good like 15 to 20 clips, or at the very least 10 plus clips that I can use in various ways. Something that sucks is that I might actually not be using all of the clips, because um, I guess it'll depend on the algorithm that I'm using. I still have to work on the algorithm itself. I have to work on the rolling logic, the rolling window logic. Hold on. Hold on just a second. Okay, sorry. I was just looking something up. Okay, all right. So, yeah, what was I saying? Sorry. I was just looking something up. Okay, right. So, um now what do I have to work on? there's I think I need to I think I need to spend some time learning polars because the rolling window logic, I think I'm gonna need some sort of data frame library for it, and I don't want to go back to pandas. I would prefer to do it with polars right now. That sounds wrong. I would prefer to do it with uh, I would prefer to use the polars library to do this. Um, and yeah, that's why I need to because I'm still a beginner in polars. I would prefer to speed that up and finish learning at least the basics of polars, so I can then go on to implement the um, the rolling window logic. Also, I mean, I should be learning polars because there's going to be a fair bit of like data handling that goes on in all of these multiple steps. Actually, there's so we have the metadata, we have the segment manifest. There's definitely a data frame that needs to be generated here. In the metadata thing, I still have to, dude. Okay, because generating the metadata is going to require a different set of steps, a different set of instructions, and then generating the segment manifest is going to require a different set of instructions. Um, because generating the metadata is one thing, right? We have uh, we analyze the entire. In fact, okay, I feel like generating the metadata is going to be much simpler in terms of like what I need to do. Ooh, outlines, dude. Okay. I need to. Yeah, I need to write down stuff here. How do I um okay, learn how to remove silent segments using FFmpeg. Definitely need to look into that. Then sliding 60-second windows in 30-second strides. Then generate video metadata using NLP and LLMs. There's the title. There's well, title is not going to be yeah, so that's going to be read from VOD titles. That's not going to be generated. Description. Chop transcript. I like that I wrote all of this down. Okay. Chop transcript into chunks, generate a summary for each chunk. Oh, this is the summary generation thing. So like basically we chop it up into smaller chunks and generate summaries for each of those chunks. And then once we have like short summaries for each of those chunks, we kind of combine them together and generate like a bigger summary of that. Um, yeah, yeah, okay, yeah. That's what I had written down here. Um, this should end up this should end up being much smaller, easier for the LLM to digest, and it should fit well within the YouTube video description limit. True. Okay. Then we have hashtags and keywords and the category. Category I can do zero shot. That's okay. What else? Oh yeah, there's the um, segment manifest. Generate segment manifest data. Just a second. Just remembered something that I need to do. Okay. Right. finish learning polars. That was, yep, okay, that's done. Continue learning. We still need to do that. Continue working. We are currently doing this. Um, right, right. Okay. So with metadata, we're going to be generating these four things: description, hashtags, keywords, and category. Okay, great. For the segment manifest, what we are generating is this table that you see in the top right. The table is basically going to be it's basically going to be this. Yeah, this is a better way of showing it. It's going to be this. What do you call it? It's going to be these rows. It's going to be segment ID, category, start, end, the start timestamp, end timestamp, duration, and then a title and a caption and a confidence score. In fact, the confidence score, I kind of feel like I need to do something there. Maybe I can expand that into multiple different categories of confidence scores. Like, I still have to figure out what the category is, because I don't know based on what I want to, like, what am I giving it a confidence for? Is it, is it, because like when you give a confidence score, it's more like, okay, we have this set of labels. We have, like, I don't know, 5 different labels. And what do we think this video, what do we think this video falls under? So whichever one of those categories we think the video falls under, we're going to give that specific category or that specific label the highest score. So these are essentially just probability scores that we are creating here. And how am I calculating this score? I don't even know that. I'm gonna have to figure something out there. So yeah, there's gonna be a bunch of stuff that I have to do here. It should be interesting though, because it's gonna be a new experience for me. Essentially analyzing a video to determine its entertainment quality. It should be interesting. I'm gonna be applying these various where is it? Wait, let me save this. And then here, I'm going to be applying the various things that were being taught over here. Maybe not all of them. The thing is, I remember there being another. Oh God, why is it freaking out? Okay. I remember there being another. I remember there being another file. Oh, we are already in empty directory. I remember there being another file, but I can't remember, like, where exactly it was. Um, was it Gemini explains NLP with? No, I can't remember. Okay, so we have AutoClipper, Gemini info. Okay, that's fine. Electronics explains advanced wave concepts. I need to get back to this as well. Holy shit, I completely forgot about this. Okay, explains advanced wave concepts, digital audio, Fourier and music, learning analog electronics with so and so. We need to get, dude, we need to get back to that. I was supposed to start doing that on stream. Learning analog electronics with microcontrollers. It is, what is this? Okay, whatever. Yeah, this, I completely forgot about this, dude. We were supposed to be, so basically learning analog electronics with microcontrollers. I've created this, wait, what do I have here? I guess I can open it up here. NeoVim, wait, that's a MD file. I could use Frogmouth for this. What is it called? Oh, let me just copy the thing. Oh God, what just, okay. I should be careful with that. I wanted to copy this and then come here and paste it and open it up here. So here I gave this entire story of, like, yeah, I wanted to learn analog electronics, and this is my history with learning about electronics and so and so, so and so. And then I was asking, is it possible to learn analog electronics using using my using microcontrollers? Because what I had noticed over the years, and especially once I got into microcontrollers and started doing digital electronics more instead of analog electronics, what I noticed was that in schools or even these electronics or robotics camps or all of those kinds of things, kids were being taught, they were being introduced to electronics using microcontrollers. So I was like, okay, what if I try to approach this in a different way? Because in the past, a lot of times when I try to learn analog electronics, I mean, I have very basic analog electronics knowledge. My level of knowledge is very limited when it comes to analog electronics, but I'm able to set up a very simple. I'm not set up. I'm able to do very simple circuit calculations. Give me a second here. So, um, yeah, my knowledge is very limited, and my issue is that each time I go to learn analog electronics, there's a whole bunch of stuff to read. There's a whole bunch of theory that you have to get into you can um, before you can actually start doing stuff practically. Whole bunch of theory. There's a lot of theory that goes into it to explain, things from the from the beginning, from like scratch. And while that's great for the sake of learning, it doesn't work for me. There's actually a lot of people that it doesn't work for, but like I'm speaking about myself specifically. It doesn't work for me. I get distracted, and I'm not gonna stick with it for very long if I do end up taking that route, which is why I don't want to take that route. Instead, because I know that microcontrollers get me excited, and I it's able to maintain my attention. It's able to keep my brain stimulated enough that I'm able to keep my attention on it. So I know that if I'm learning through microcontrollers, I'm going to be very much interested because there's constant like feedback that you're getting in various ways. So that's why I was like, okay, let me try learning analog electronics through the use of microcontrollers. And this is kind of like, I don't know what to call this situation. It's one of those situations where it's like, okay, I know the basics of electronics. I'm looking to get higher analog electronics knowledge, but like even mid level, not even higher, mid level. I'm looking to get mid level to advanced electronics knowledge in analog electronics. Where was I going with this? Oh yeah. So this is one of those situations where it's like, okay, I know the basics, but I want Gemini to approach this as if I don't know the basics. However, and this is where it gets a little weird, what I'm telling Gemini is that I don't know anything about analog electronics, but I know a lot about digital electronics. So I just want you to assume that I have I know how to work with an ESP32. I know how to I've set up the Rust toolchain for the ESP32. I've I know how to set up a very simple circuit. I have this list of components. I believe it wasn't here. It wasn't here. It was somewhere else. Hold on. I definitely had it. I had it somewhere here. I just don't remember where I put. Oh, this is probably it. The prompt. Um, right. Let's. This one probably requires NeoVim because this is a text file, not MD. Did I never make this an MD file? Gemini Electronics prompt. I don't remember. What about here? Gemini Electronics syllabus. Oh, I did get Gemini to generate a syllabus. I completely forgot about this, dude. I did this for a little bit and then I just didn't look back at it again. But yeah, let me open this up. So this was the entire prompt that I generated because I had to like after testing this out with Gemini a couple of times, I realized that okay, there's parts that I need to mention to Gemini. There's various things I need to mention to Gemini. I actually used Gemini to help me refine this prompt. So okay, we can go over this again. So Gemini teaches analog electronics through the use of microcontrollers. And then I mentioned these are the parts that I have available because fortunately I do have these parts available. Um, I have, a breadboard, switches and buttons, jumpers for the breadboard. Um, I have 3-volt LEDs. I have assorted resistors, assorted capacitors, assorted transistors, assorted diodes, a couple of different potentiometers. I have some 555 timer ICs. That's definitely useful in analog electronics. I have optocouplers. Once again, holy shit, dude. Huge shout out to Ellie Minibot. If I hadn't seen her stream where she was hacking a game controller, I wouldn't have learned about optocouplers. Optocouplers have really changed things for me because okay, not knowing about optocouplers was one of the reasons why I was never fully comfortable with hacking circuits using a microcontroller. Because often when it comes to hacking circuits, you would need some sort of electronic switch, right? In the electronics world, the electronic switch is a transistor. So essentially, there's three legs. Two of the legs are connected to the bridge where you wanna let current flow within that circuit that you're trying to hack. So you connect it to two points, and then the one remaining leg is where you have to give a small signal, and that's gonna then let the let the current flow. So this is how you insert a transistor into a circuit. But the thing is, the thing that you're connecting that third leg to, that's your microcontroller circuit. It needs to be either that side needs to be connected to ground, or if it's being connected to positive side, then the ground of that circuit needs to be connected to the ground of the circuit that you're trying to hack. And that's where I wasn't comfortable with doing it, because like imagine I'm trying to hack a 12-volt circuit, but the microcontroller only operates at 3.3 volts. Then like I'm not very comfortable with. There are specific ways of setting it up, but that doesn't negate the risks within that kind of a circuit. So unless I was like completely sure about what I was doing, I didn't want to just plug my 3.3 volt microcontroller into into a much higher voltage circuit. And optocouplers, they solve that problem because optocouplers allow you to have the power of what a transistor can do, but with the isolation. So they essentially allow you to create an electronic switch while also maintaining isolation between the control circuit and the circuit that you're trying to control. Um, it's worth mentioning that while they are fast in their own right, they are not nearly as fast as actual transistors. So at a certain point, yes, you would need to use a transistor instead. But for the most part, like there's a lot of different types of applications, and especially if it's like one-off hits, like a button press or something like that, you can get away with using an optocoupler for that. Okay, anyways, carrying on. Then I have a couple of comparator ICs as well. That would be interesting to get into with analog electronics. And I have a couple of logic gate ICs as well. I also have, I believe it's a shift register that I had ordered. And I think one or two other things had come with it. I don't remember exactly what they were. Maybe a binary decoder or I don't remember. I got a couple of ICs. I haven't mentioned any of those. I mostly mentioned stuff that I felt would be closer to analog than digital. I didn't want to get into digital. Okay, so then we have the prompt, some backstory, and yeah, that was the entire backstory of like how I got into electronics and how I got. Okay, what was the last line here? Uh, Actually, last two lines. Okay, I never really dove too deep into analog electronics. I also never got a chance to dive too deep into the calculations for various components like capacitors, diodes, etc. Something. Okay, I just remembered this. And this gets mentioned later on, and this was like the advantage of refining the prompt using Gemini. Um, Something that I did mention in this prompt, which will be shown later, is that I didn't want to go into calculus at all. I didn't want to touch calculus. So anytime calculus is involved, Gemini should find a different way to teach the thing to me. Fortunately, there are a lot of um, ways to get around that, and situations where calculus is involved, it's usually to generate an equation. But if I already know the equation, I don't need to touch the calculus part. Um, okay, I also never got a chance to dive too deep into so and so. I did learn calculations for resistors and a little bit of BJT transistors, which is true. I did learn it. Even transistors to a certain extent. I learned the calculation, but that was about it. And then I never learned that whole thing of solving circuits. I learned Ohm's law, but for very basic circuits, I never touched Kirchhoff's law or Kirchhoff's law. Okay, now let's forget I know anything about analog electronics and pretend I'm a complete noob at analog electronics. You are a tutor. You are going to teach me analog electronics. You are going to teach me all about analog electronics, starting from the basic electronics concepts, going into discrete components, and eventually building complex circuits. But there's a twist. You're going to teach me with the use of MCUs, which is microcontroller units, specifically ESP32 and Rust. I already know how to program an ESP32 with Rust. I have set up the ESP32 Rust toolchain already. I know how to create an ESP32 Rust project and enable various features while creating it. I'm doing bare metal, which is no STD Rust. I felt the need to mention this because later on, when I was testing out the prompt, I noticed that Gemini, for the sake of being helpful, Gemini was giving me responses saying, okay, if you are using STD, then do this. If you're using no STD, then do that. So I was like, okay, if I just narrow it down, it'll be much more simplified. So if because I'm not using STD at all, I'm specifically, oh, accidentally hit my mic. I'm 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 solely sticking with no STD. Okay, I'm doing bare metal Rust, bare metal no STD Rust. I have an ESP32 connected to the system, and I know how to compile and flash a Rust binary onto the ESP32. The entire environment is set up and ready to go. Start by generating a syllabus, split it up into chapters. For each chapter, make sure I have an exercise so I can practice what I've learned. Print out the syllabus here and also serialize it to JSON and write it to Gemini Electronics syllabus.json. This is where that syllabus came from. Oh, would I be able to hold on? What does the JSON look like? Does it have? I need to look at this in TV. I mean, okay, I can just open it up here. Let's go back. Gemini Electronics, and then Gemini JSON. Okay, do we have similar fields? I think so. I think so. Okay, so if that's the case, here's what we can do. I will, hold on, I need to come here. We can close this. I need to find a way to, okay, so we'll import JSON file. Oh, yeah, that's going to be a problem. Now, wait, let's go back. And here, let's do TW, go back, Gemini Electronics, and then Gemini so-and-so. Damn. Okay, that's not going to work. That is not going to work. Is this good enough? I don't know. Hold on. What is this? Oh, yeah. What if I pipe it through BAT, I guess. So we have, okay, so we'll do this, and then JQ, and then BAT L JSON. This is more or less the same as if I use NeoVim here. I could just enable wrapping and then we get the same result. Yeah, actually pretty much the same result. Yeah. Um, okay. Yeah, let's go back to having this thing open and then come back here and we will read this. So what was a method that I was using to kind of visualize JSON data? And why isn't this working? Oh, it's because of syllabus. It's because of syllabus. What if what if I edit this? I'm hoping, okay, I'm hoping, I don't remember where I was going with that. Let me, okay, hold up. Dude, this is so silly. I'm doing all of this just to be able to view the thing in what do you call it? Okay, well, I mean, I'm doing it now anyways. Um let's yank this and paste and rename this to TW underscore so and so. And um, let's open up the thing. So we're going to Gemini Electron. Oh God, don't do that. Um, can I do dot here? No, I can't do dot here. We're going to go back. We're going to do this. Gemini Electronics. Gemini, this one. Okay. So we need to delete this. We need to delete this as well. I think I'll need to select all of this and then remove one of the indentations. Okay, so we'll select all of this. I don't think the indentation should be too much of an issue, but yeah, okay. So now this is .json tw underscore. Okay, there we go. So this is our data, and we have the information here. We can scroll oh, nice. Okay, it does the line wrapping as well. See, knowing JSON syntax to a certain extent, it did help because I was able to clean this up. With the other with this format, what would happen is this would load a JSON object or a JSON dictionary if I'm loading it up in Python. Actually, I'm not loading this. Why am I worried about that? I'm not loading this. But yeah, if I did load this up in Python, it would load it up into a dictionary, and that dictionary would have only one key, which is called syllabus, and that syllabus would have a list of dictionaries, and each dictionary would be a chapter, and then each of the keys in that would be, you know, stuff like chapter number, title, concepts, MCU skill, and so on. Okay, so this is our first chapter. Actually, this is a pretty decent way of viewing this thing. Even though, like, in this form, maybe it's not the best. However, in this form, it's much better. And I can also scroll the data. Um, wait, does it? Oh yeah, it respects the scroll. Um, even as I switch to different rows. Okay, so in chapter one, actually, I can see which chapter I'm in. The concepts, introduction to the core tenets of electronics, voltage, current, and resistance. We will master the fundamental relationship that governs them, which is Ohm's law. MCU skill, calibrating the ESP32s. Oh, I remember this. Yeah, we had to do. Wait, I forgot about this. This is not gonna open up properly. You know what? We're just gonna view the entire thing in NeoVim. We're not gonna try fighting it. So in chapter one, this was gonna teach us about voltage, current, and resistance. And for practice, we were going to need to calibrate the ESP32 to be able to use it. Well, calibrate the ESP32's ADC, the analog to digital converter, because the values that are given, there was something to do with the range that they are in. We needed to make that range linear. Or I guess we needed to figure out the mapping. What does it what does the description say here? Create a variable create a variable voltage source with a potentiometer and write a Rust program to map the raw ADC readings to a precise voltage scale. Um, it mentions titles. Oh, yeah. There's exercises. There's two exercises. One is the calibration, and the other is Ohm's law in practice. So the reason we need to do the ADC calibration is so we can actually use this um, this microcontroller as a voltmeter to measure the voltage in the circuit. I don't remember if we are doing current here or not, but let's read the next exercise. That was going to be Ohm's law in practice. Construct a simple voltage divider circuit. First, calculate the expected voltage at, and okay, here's the thing, right? All of this is like in simple like bullet point style, but the actual chapter is going to be much more detailed. There's going to be a bunch of explanation. There's going to be a whole bunch of explanation about what this chapter is about and the various concepts that are being explained here. And then for each exercise, Gemini is going to give a bit of an explanation for what we are doing and why we are doing it. And yeah, it's going to be much more detailed than what we are looking at here. Right now, we're just looking at a syllabus. So we're just seeing like an overview of it. We're just seeing like headings. And even this description, these are short descriptions. They're not meant to, it's not meant to detail out the entire chapter right here. Yeah, so construct a simple voltage divider circuit. First, calculate the expected. Dude, you know what? I remember, um, I remember actually testing out this prompt and then questioning Gemini about what a voltage divider is, because I'd heard about voltage dividers in the past. I'd never actually used voltage dividers. Uh, the, so the basic idea with voltage dividers is it's just dividing the voltage into half. It's a way to reduce the voltage if you ever need to. Um, Without, I believe it's without reducing the current. I'm trying to remember if you do ever reduce the current. No, I think it's mainly reducing the voltage. So if you have something that requires a much smaller voltage, um, and you only have a higher voltage source, then you can use a voltage divider to split that voltage into half. Okay, chapter 2, circuit composition, series, parallel, and Kirchhoff's law. Learn how components behave when chained together in series versus in parallel. We'll use Kirchhoff's law. Dude, you know what I'm wondering? I'm wondering how different this would be if I set it up using an agentic workflow or using agentic AI. To be fair, I was planning on using Gemini CLI, which is already agentic. Um, but like, I'm wondering if I could achieve something better by self-hosting some sort of agentic AI. The problem is I don't have good enough hardware to do that. I also don't have like a separate dedicated machine that I can, keep for the agentic AI. So I don't know if that's really gonna work out. But okay. Learn how components behave when chained together in series versus parallel. We use Kirchhoff's laws simplified for our needs to understand how voltage and current are distributed. How come Ohm's law is not being mentioned here? Ohm's law was mentioned up here, but here down here it's using Kirchhoff's law. Okay, okay. Mixed resistor network analysis. Okay. Use the ESP32 to probe and measure voltage in multiple points in a live circuit to map its behavior. All right. Then mixed resistor network analysis. Build a mixed series parallel resistor network. Calculate the voltage drops and currents for each part of the circuit on paper. Then systematically move your ESP32's ADC probe from point to point to confirm that your theoretical calculations match reality. Okay, then we have the time element. Understanding capacitors, then we have RC. Oh, that's one of the exercises. Okay. Introducing introduction to capacitors and their ability to store charge. We'll explore the time constant of an RC circuit and use algebraic formulas to predict how voltage changes over time as the capacitor charges and discharges. Programming the ESP32 to act as a data logger, capturing the voltage curve of a charging capacitor at high speed. All right. One-way gates. Oh, diodes. Okay, great. Then control and amplification. This is transistors. Okay, then we have the first IC meet the 555 timer IC. So at this point, we will have learned about resistors, capacitors, transistors. I don't remember if we have touched LEDs so far. Yeah, I don't remember if we've touched LEDs at this point. I feel like all we are doing so far is like measuring the voltage being the voltage and current being put out by the circuit at different points. Yeah, I don't think LED has been mentioned so far. Oh, I see LED here though. Transistor as a switch. Okay, this is probably where we're going to be using LED. Maybe LED was mentioned up somewhere up here as well. I don't think so. Because even with the transistor, I don't know where the charge is going for the transistor. Maybe it's just going to ground, so it just like discharges over time, and we are reading what the charge is. Yeah, I think so. It doesn't. Wait, I can search for the term LED. Okay, we have LED mentioned in two places. Once in so there. Okay, so it's there in it's there in transistors, and then we go into 555 timer IC. It says okay, build a 555 astable oscillator. Okay, so there's going to be interesting stuff to learn here. On paper, calculate the expected output frequency and duty cycle based on your chosen resistor and capacitor values. Then use your ESP32 frequency counter to measure the real world output and see how closely it matches your theory. Okay, more ICs. This is where LEDs come in again, I believe. Comparators and optocouplers. Explore the function of a comparator for comparing two voltages, and an optocoupler for providing complete electrical isolation. So the good thing about optocouplers is that you are not limited to digital circuits. The way that an optocoupler works is you're essentially controlling an LED on one side and a phototransistor on the other side. And both of these are analog devices. So like I actually tested this out. This is actually how I tested out the optocouplers when I first got them. This is how I tested them out. I set up two analog circuits and used the optocoupler to uh, control the control one circuit from another. Man, I love electronics, dude. Look at this. There's so much to explore here. And the moment I start looking at the syllabus, there's like so many ideas that I get. It's crazy. Okay, okay. Dude, wait, real quick. I want to create a new thing here. Possible future stream. What do you call it when there's like multiple streams? Like when like we're doing multiple streams, multiple streams for a given topic. Okay, let's just say stream topics. Couple of things. Gemini teaches analog electronics. You know, I always confuse this spelling with this spelling. I don't know if there is actually a difference, or if the difference is literally just US versus UK. Because sometimes you have those kinds of weird situations, like in British English, aeroplane is spelled as aeroplane, AERO, plane, PLANE, right? That's in British English. But then you come to US English and it's like airplane. So it's AIR and then plane. So you have situations like that. I believe the spelling of color is also a British English versus US English kind of thing. So COLOUR versus COLOR. Okay, hold on. Analog versus analog. Analog and analog are largely interchangeable spellings for technologies that use continuously variable signals, like vinyl records and or traditional clocks, with analog being the preferred. Oh, yep, okay. So analog without the UE is American spelling, and with the UE is British spelling. What I'm used to is uh, the UE, so I'm going to stick with that. Okay. Gemini teaches analog electronics with MCUs. That's one thing that we could do. Then we have robotics, learn robotics. I don't know what we should be using for this though, because we do have Le Robot. Yeah, we have Le Robot. Hold on. Maybe using Le Robot. I made a mistake here. Yeah. Okay, and then we have just learning, deep learning. Again, FCN. We have not made like any progress with this because I keep getting distracted with so many different things. We have not made like any progress with this. I'm still stuck at feed forward neural networks because I I have like a bunch of other stuff that I'm doing research on and learning. So at some point we need to get back to this. FCNN, CNN, RNN, and transformer. Transformers. Yeah. Also learning NLP. I do remember, let's add legacy NLP. I do remember I had a thing somewhere here. Hold on, let me save this and come here and look at Yahtzee. We had NLP with deep learning. Gemini explains learning NLP with deep learning. Then there's NLP syllabus explained. So I have a couple of things here. I guess I'll open NLP tasks using neural networks. I think I'll go with these two things. So one of these was just NLP, not necessarily mentioning how deep learning comes in. And then this was Gemini explaining how I could mix up NLP and deep learning. I'm not entirely sure that's the best idea. Previously, I did think it was a good idea, but then after looking at how complex these things are to implement, I figured it's probably best to just learn how to use the tools, because learning to use the tools is very different from learning to build the tools. And if I'm trying to focus on NLP specifically, and trying to do higher level things with NLP, then maybe I shouldn't be focusing on building NLP tools. I should be focusing more on using NLP tools, because using those tools is actually going to be a lot more beneficial in terms of. Hold on, let's open up. Let's go back. We are looking at learning NLP with deep learning. And then here we want to do. Okay, let's open this. And then also let's, learning NLP with deep learning. And in here, one more of these. Which one did I want to open? I guess let's do this one. Okay. Yeah, so I was following this, and I remember I was using NLTK for this. I didn't go further from tokenization. I do remember that. I didn't go any further from tokenization. But NLTK does give you the tools to do legacy NLP stuff. Okay, hold on. I just noticed the time. Okay, I need to end the stream. The good news is we stream for an hour and 12 minutes. Hopefully I'll start the stream earlier tomorrow. But yeah, that's going to be it for today's stream. I'm not going to be rating anyone today. Probably tomorrow. For now, I need to get back to working on the content pipeline. I think today what I'll do is I'll continue doing the polars studies, so I can quickly finish learning the basics of polars and learn how to deal with data frames in polars, so we can then start working on the rolling window logic. Actually, that should be added to the list as well. Content pipeline. I'm already doing that. Oh, might as well add Godot with Rust. So these are the various topics that we can use. Okay, that's going to be it for today's stream. I hope you guys have a nice day, and I'll see you all next time. Peace.